Let's now create two more situations in which closures are gonna appear, so that you can start identifying closures in your own code in the future. And both of these examples are gonna demonstrate that we don't need to return a function from another function in order to create a closure. All right, so let's start with our first example here. I'm gonna start by defining an empty variable called f, and then a function expression g, so these are just some generic names because what the functions do here don't really matter. Then in here I defined this a variable, and then I'm going to reassign the f variable that we created out here, and I'm going to assign it a function value. And this function will then simply log the a variable to the console, let's say times 2. Okay, and that's it, for now at least. So let's try to call g. So that's going to be this first function. And so the result of this function is that a will be 23, and that our f variable that we have out here will become this function. And so after g, we can then call f. So let's try that. And we get 46, which is indeed 23 times 2. All right. And so what this proves is that this f value here, so this f function, really does close over any variables of the execution context in which it was defined. And that is true even when the variable itself, so f here, was technically not even defined inside of this variable environment here, right? So this f variable was defined outside here in the global scope. It was created here. But then as we assigned it a function here in this g function, so right here it then still closed over the variable environment of the g function. And that includes this a variable. And therefore it is able to access this a variable here even after the g function here at this point has of course already finished its execution, right? So that's just what we learned in the last lecture. So at this point of the execution, the variable environment of g is no longer there, right? But f, so this function here, closed over that variable environment, and therefore it is able to access the a variable. So basically, using the analogy of our last video, the a variable is inside the backpack of the f function. But now let's take it to the next level and create a new function here. So that's h, and it's going to be very similar. All it's going to do is to define b as some other value, let's say this, and then we will again reassign f right here. So let's call this one b now, of course. So this one here will then try to access b and multiply by 2. Okay? And so what I want to see with this is what happens when we assign the f value a second function. Okay? So here we call g, and so g will then assign to our empty variable this f function. Okay? And then if we call h afterwards, or actually let's do it after calling f for the first time. So as we then call h, then the f variable will be assigned again. So then a second function, which is this one here. And so what I want to see is what f does then. So let's see. And again, keeping in mind that f at this point is a different function than this one here, because it was reassigned by h. We just write that here. Okay, and now we get 1554, which is probably 777 times 2, And indeed, it is. And so this proves that the f function that was reassigned here also closed over the variable environment of age. And so that's how it can access then the b variable here, which is set to 777. So let's actually inspect the variable environment like we did by the end of the last video. So of f. And then we will be able to see that in the closure, it does indeed have the value of b. And it now no longer has the value of a. So of the closure that it used to have before. So at this point here, the closure contained the value a. And we can, of course, also see that. So at this point in time, the closure is indeed a23, right? And so then as we reassign the function to a new value, then that old closure basically disappears. And yeah, now the closure is b. So this variable here of the birthplace where it was reassigned. And this is really fascinating in my opinion, that the closure can change like this as the variable is reassigned. So it really is true that a closure always makes sure that a function does not lose the connection to the variables that were present at its birthplace. So it's always going to remember them. And in our case here, the function was kind of born inside of g first, and then it was essentially reborn again in age. And so first, the closure contained the a variable of its first birthplace, and then as it was reborn, to follow our analogy, then it remembered this b variable of its birthplace. Okay? So this was example 1. Let's now create another example. Okay, so I hope the first one was clear here. So whenever something like this happens, where you reassign functions, even without returning them, keep in mind that also this will create a closure. But now moving on to our second example here, and that's going to be a timer. So a timer is another great example that we don't need to return a function to see a closure in action. So here I'm going back to the example of the airline. So creating a function called board passengers. And then we get the number of passengers and a wait time. Then let's create a new variable in here, which I'm calling per group. And that's because boarding usually happens in groups, and we usually have 3 groups. So I'm going to divide all the passengers, so the number of passengers that is boarding, by 3. And by the end of this function, I want to log to the console, we'll start boarding in, then wait seconds. Okay. And now let's actually use a timer. And we haven't actually used a timer yet in this course, and we will learn more about them later. But this is such a good use case that I wanted to use a timer now. And it's actually very simple. So we just use the set timeout function. And the set timeout function needs 2 parameters. The first one is a function which will be executed. Okay, and this function will be executed after a certain time. For example, we can specify 1000 milliseconds because the second argument here is milliseconds. And so that will mean that whatever code is inside of this function will be executed after 1 second. So let me actually do that out here, just so you see this as an example. So if I save this now, wait 1 second, and then here you see timer appearing. So I'm going to do that again. Okay. So you see that after this 1 second, this function was executed. Okay. And so this, as we already learned before, is essentially a callback function. And in this case, it is literally called later. So in this case, after 1 second. So let's create our callback function here. And first I want to log to the console. We are now boarding all and then the n passengers. And so this n here is this parameter of the function. So of this parent function, which essentially is the function or the scope in which this callback function here is being created. And so that will of course be important for our closure example. And then let's also use the per group variable now. There are 3 groups, each with passengers. Okay, that's our function, and now let's call it. Oh, and here we want to specify weight, and then times 1000, because we're going to pass in the weight in seconds. And this argument here needs to be in milliseconds, and so we just multiply by 1000. So, board passengers, let's say we have 180 passengers, and it takes let's say 3 seconds. So immediately when we call this function, this variable will be created, then setTimeout will be called, and it will basically register this callback function here, and then that will be called after 3 seconds. But immediately also this console.log here will be called. All right. So this console.log here will not wait these 3 seconds for the setTimeout callback to finish. Okay. So immediately this variable is created, the setTimeout function is run, and console.log is run. And then after 3 seconds, this function here will be executed. And so let's see what happens to the n variable and to the per group variable that is in this function. So immediately we get this log. And then after 3 seconds, we are boarding all 180, and there are 3 groups with 60 passengers each. Okay, it worked. And again, keep in mind that this callback function here was executed completely independently from the board passengers function. All right, but still, the callback function was able to use all the variables that were in the variable environment in which it was created. So that's n and per group. And one more time, this is a clear sign of a closure being created, right? So the only way in which this callback function here can have access to the variables that are defined in the board passengers function that has long finished execution is if it created a closure. And so that's exactly what happened. And yeah, that's how we got access to per group and also this argument of the function. So this weight here, right? So as I mentioned in the last lecture, the closure, of course, also includes the arguments, and that's because they are really just local variables in the function. And to finish, let's now also prove that the closure does, in fact, have priority over the scope chain. So here in the global scope, I'm also going to create a variable called per group equals, and then just some value here. And so if the scope chain had priority over the closure, then this callback function here would indeed use this variable here, this global variable, because we can imagine this function here basically being executed in the global scope. Okay, so if it wasn't for the closure, it would use this. So let me actually demonstrate that to you. So if I remove this variable, then it will be able to use the per group. And that is here outside. So indeed, now we get 1000. But then, as we put it back here, then the callback function will close over this variable. So it will close over the entire variable environment, in fact. And so therefore, it will then use this here first. Right? And it did. So, in fact, the closure even has priority over the scope chain. Okay, and with this, we finished these 2 lectures about closures. And I hope that after this one, you are now a little bit better able to identify closures as they happen in your code, or even here in my code throughout the course, because we will see some closures happening some more times in the future. Now all there's left to do is the coding challenge in the next video, where you will be thinking about closures one more time.